Alright, so I think we're on to part 6 of this Siemens SCL examples. So I want to write some function blocks to control these actuators. So I should be able to write the same function block to control the gates and the clamps and this gantry crane thing here. So let's do this. So I'll post, this is the project from last time, and I think I found a bug here. Basic place, clamped outfeed, yeah. What did we do here? I think we'll have to double check that. Well, I guess we'll open this one up. When I was looking through this week, I found a bug. Debounced inputs, infeed, clamped gate limit. Oh, I didn't put a, I didn't have this outfeed debounce called. If you guys ever find bugs, just let me know and we'll try to fix them. The raw input is outfeed. We're going to use this. Alright. Save that. I guess we can compile and download that. Okay. Okay. So, while we're going online, so we're going to make a new FB. Station 1. Well, this is going to be in our framework. We're going to add new block. Function block SCL. So my framework blocks here, I just let them number automatically, but when we put the one in here, we'll try to stick to our numbering convention. I'm going to call this one actuator control. It's SCL. Yeah. Throw that guy in there. Okay. So how I want to set this up is I'm going to have a command. I guess and then that we're going to tell this actuator to clamp or release. You know, this product clamp or part clamp here, the part locator. So, and we're going to say maybe if the command is 0, we're done. And if the command is 1, we're going to find our position or home it up. And if the command is 2, we're going to go to home position in manual mode, which would be released. And if it was 3, we're going to go to our clamp position or our work position in manual mode, and then 4 and 5 for automatic modes. And we want to do this like with an integer or something like that, so that we can't send 2 commands at the same time. We can't tell it to open and close. We can only tell it to do one thing. And the numbers we choose are kind of arbitrary. Ideally, a person would have like a framework and stick with them. But we'll put them into constants and we'll handle them like that. So we are going to have an in-out because we're going to be reading our command, and then when we're done with our actions, we're going to be writing it back to a 0. We're going to have a command, data type int, and then let's do this. I'm going to jump around a little bit, but there's a couple things I want to do. I want to get an edge and see when an integer has changed, and use that to set a bit. If I remember correct. Well, we'll go piece by piece, but I think that we're going to have to write that in order to make this kind of work. So we're going to use our case statement, and we're going to say case of command. Okay, so let's do this. We're going to have command done. That's going to be an int, and its value is going to be 0. We're going to have a home command. It's going to be an int, and that value is going to be 1. We're going to have, I guess I'll leave some space for it. Maybe we'll have manual typing. Manual home, manual move to home. Let's do that. Move to home position command. Let's make it 11. And then we're going to have manual move to work position command. It's going to be 12. We're going to have auto move to home position command. It's going to be an int and be 21. Auto move to work position command, int and 22. Okay, so in the case of command done, okay, and then I'm gonna make an else, and I'm gonna say, well, we'll put the else in a minute. So if we have, we could have home command, we could have manual move to home position, and then I'm going to put comma, comma. So that's going to, or I just need one comma. That's going to say, in this case, we're going to look at this value or this other value. If you put period, period, that's going to do from this value to this value. So manual move to home position or auto move to home position. And then semicolon. Okay, then we've got one more. It's going to be manual move to home position, comma, because we're saying this or this, and we're going to put condition or actions and conditions under these to drive how we operate this. Manual move to home position command or auto move to work position command. I need to fix that one there. Okay. Put our semicolon just to make it pretty. And then what I like to do with these case statements, so I like to use a constant here, but then I like to leave the comment in, and I'm going to put some more information about, like, this is command 0. And let's copy that. Command 0, no, that's command 11 or 21. This is command 1. command 12 or 22. Okay, now the else statement. So what we're going to use for that is a catch. If we don't have, I'm going to go close the door real quick. Oh, it is closed. Okay, so we're going to say if we don't have any one of these commands, like somebody passed in a 99 or something, we're going to just set our command to command done. A person could have like command error or return, set a return value that says unknown command, something like that. But so we're going to say if somebody sends us a bad command, we're going to assign it command done. Okay. So then that's going to jump up to here. On the next scan through, and we don't really need to do anything with that. Maybe we could put a return. But actually kind of doesn't need to be done. We'll see what we can, if we need to add anything like that. So, something that we run into on this machine is being that there's not a feedback for a work position or a home position, and we're using the movement or the outputs with edges and one area of feedback. It's real easy to, on the initial startup of the PLC, we won't have position. But if something is in the extended position on the initial scan of the PLC, we're gonna have to do something to tell it to come back to the home position. If it's in the home position, we can't drive our output and set this bit. It's kind of a catch-22 that's with it. So we're going to put in our home command cycle, we're going to look to see whether our output is on or off. So we're going to say home position output and work position output. These are going to be data type bools. I want to examine these on the home. Okay. Okay, let me see if I can pause this video. Alright, let's get back to it. Okay, so I need to say home command. So I want to look to see if our home position output is on. So I'm going to say if home position output, then, and we're going to do a thing. Else, we're going to do a different thing. Okay. So if our home position output is on, then I want to turn that off, and I want to turn on our work position output. And the reason that I want to do this is I want this to extend out, and I want it to come back so I have that edge on my movement or my edge on my sensor, and I can set my home position again. So if home position output, then I'm going to need these. I actually meant to make inputs. Let's make it move to home position, move to work position, Okay, and I might move that up there just for the sake of consistency. So if home position output, then move to home position is going to be false. Move to work position is going to be, well, yeah, going to be true. And then we are going to return. See if that's how I remember how I want to do that. So, and return lets us jump out of our function call or our function block. And we come back to it again on the next scan. So, then we want to, I guess maybe we want to put steps in here. Let's do that. Let's cut this. Let's paste it down here. We'll come back to this. I remember thinking this was going to be one of the trickier videos. Okay, we're going to do a state machine inside the home, or inside this home. So we want to say, let's put in step. Yeah. It's going to be data type int. Okay. We are going to check output step. That's an int, and that is 0. Okay. And then that'll give us actions. This is step 20. I think I got a typo here. Step 0. Move. Yeah, let's do that. Move to work position is step 10. Move to home position. No. Move to home position step. Space. Step 20. Okay, yeah, so that's kind of what I'm thinking with that. Then we're going to have an unknown step. Else step equals, we're going to say check output step. Okay. Yeah, okay, so here's my thinking now. Okay. Yeah, we'll just start over with this. Okay. So we want to, if we tell it to home, we're going to check whether we have our output on or off. If let's see, how do I want to say this? If home position output, yep, okay. If home position output, actually I think I can put these as in-outs. We'll see. It's been a little while since I had to write this, so we're gonna have some a little bit of learning curve with this too. If home position output, then we're gonna set our step to move to work position step, okay? Else, we're going to set our step to move to home position step. Yep, okay. So we're going to come into the sequence, and we might do a way to manage this step. We're going to, if we get a new command, we always set the step to 0. So in case of step, then we're going to do our check output step. If our home position output is on, we're going to jump to work position. If our move to home position, or otherwise, we're going to go back, we're going to move to our home position. Okay. So, move to work position, we are going to turn home position output off. This is like earlier. And our work position output is going to be true. And then how do we leave this step? We're going to leave this step once we actually do get to our work position. So we're going to put an if statement here. And we're going to say, if we get to work position, then we're going to do something there. And what we're going to do is we're going to tell it now go to the home position step. Okay. So what we're doing here, we're checking our output. If our home position is on, we're going to tell it jump down to, or basically on the next scan, go to this move to work position. On the move to work position, we're going to move to work position. Once we're there, we're going to go move to home position. So, I like to put a return after every single one of these steps. I guess we need to put it inside the step, or inside the if statement. And the reason I like to put them there is so that you can't have more than 2 steps happen in a scan. And I don't want the steps to happen more than 1 step in a scan, because I might want to push this data out to a historian, or even check in my trace to see how my steps are running. So, okay, we're going to check our output. If we're in home position, we move to work position. If we were in work position, or now we're in work position, then we're going to move to our home position. So this is pretty easy. It's almost the same. Only we're going to flip these around. And then we're going to say home position and if we have our home position, step is going to be, we're going to set it to, let's make a done step. And then let's also set our command is going to become command done. All right. So guess we can, I want to pack that into an FB, and we'll do some testing on this. Add new block. So I'm going to do one that's called clamp control. It's going to be an SCL. Let me add a new group. Add a new group. Actuator control. In there, we're going to put actuator control, and we're going to put clamp control. So in clamp control, we're going to take that actuator control we just wrote. We're going to make it multi-instance, actuator control instance. I'm going to do this because we're going to be doing a little bit of voodoo in the background. Like, if I remember right, we made a data type to handle this home and work position for clamps. PLC Data Types, Framework, Clamp Position Data. So now I can take these and say, released is our home position, clamped is our work position. We're going to have an in-out that's a command. Int. And then I don't think we had outputs to drive them, but we did have we have our work position output. We only have one output that drives this back and forth, and it is our work position, because when it's 0 we're homed, and when it's 1 we're at work. So we are going to put an in-out called clamp cylinder output. That's going to be a bool, and that is going to go to our work position output. And then we are going to make a temp called release cylinder output. That's going to be a data type bool, and it is release cylinder output equals, or as assignment, not clamp cylinder output. And then we're going to use this guy to drive that guy. Now let's put it station 1. Let's go back to this. We're going to make a new FB, add new block. We're going to call that, we're going to call a couple of actuator things in here, but we're going to do just one at a time. So we have station 1 actuator control. Oh, I want to renumber that and talk about my numbering scheme. So because this is in, say, our first module or our first machine, and it's in our first station, I'm making them all 1100. Why can I not change that? Oh, I have to go offline to do that. Okay, that's right. Now we can renumber. So, and then I'm taking like our first called FB and making it 1101, 1102, 1103. I think this one is going to be, we might have a couple in between here, so I'm just going to set it to 1107, but I'm going to go back and renumber them when we're all done. In here, we are going to call actuators, clamp control, multi-instance, got it, and we have our clamp position data. I think I screwed up the name on that. Let me go back and fix that. Oh. Okay. That's going to go to there. We have our command, data type int. And then we have, oh, that's going to be an in out because we're going to be looking at it. Clamp cylinder output, data type bool. All right, now we need to call this guy in our OV1. Let's see, actuator control. DB, I'm going to set it manually, 1107. Okay, and now I can pull, oh, I need to, yeah, I'll show you that too. I'm going to add a row called actuator commands. It's going to be data type struct, okay. Easy puppies. Okay, and then we have our clamp, and that's data type int. And then we have clamp position data, which remember our position status, clamp, we can push that into there. Our command, we can push that into there, and our output, station 1 outputs, clamp base. Okay, let's download this. Oh, what do we got an error of? Software completed. Or we got an error. Let's go to properties, see what that is. Info. No go to. I didn't do a go to. Oh, move to work position step. Yeah. Let me try that now. Alright, now it's time to do the debug. I wonder if this is going to work or if we have any snags. So if I go to this and go live. Okay. I like that. And see how it wrote back to 0? Let's open a watch table and let's turn on our output and put it in the work position, because that's the one snag that I didn't want. Watch and force tables, station 1. Go online. I want to get rid of this one, and the clamp base is going to be Okay. Say we powered up the machine or we had a fault and this is where we're at. Can we get it if I tell it to home? Oh. Okay, so we ran out. Let's work on the debug, but we didn't jump back in. So let's see what step we're in. So if we go to Station 1 Actuator Control, and we go live, Clamp Control Instance, where did I put my step at? It'd be in the static. Step 0. Oh. Okay, we are in the home position. That's right. Yeah, because we're released. Okay, so if I tell it to home from here, okay, yeah. Okay, so we're in the home position, and I'll show you where the hang up is in this. Position clamp. Like, let me write this. Toggle value. Yes, I want to toggle. Oh. Can I jump to my initial values? Yeah. I should be able to. I could hit stop and then run. Yeah, okay. So we came in. We don't know our position on this. We don't know if we're extended, if we're closed. All we know is that it is, we can read the output of it and see that the output's off. So that's why we want to tell it. Okay. Now we should be able to take this. I think we're going to run out of time on this video, but we should be able to take our actuator control, and with just a little bit of work, the same way we could repack it for our gate, and then we just call them both in the same instance there. Oh, but I guess we still need to work on our, we'll see if we have time. We'll push through. Okay, so we tell it, if we want to move to the home position, oh, that's easy. Move to home position step. Basically, we want to do all of this stuff. If we tell it to move to the home position. And if we tell it to move to the work position, we want to do what do we lose here? We don't need to manage our step in this. Oh. No, I need to do an end if. I cut it off. Get my syntax messed up. There we go. Okay. So what is the... Oh, and I need to put my end if here. Gonna indent these. I think there's a quick command to do that. So if I download this, I should also be able to put in my other commands. Load 11 or 21, 12 or 22. Let me look to see what. So we want it to move to the work position, command 12 or 22. If we do that, I'm going to turn on work. Okay. And then if I tell it 11, it should go back. Okay. If I tell it 21, it should go forward. I might need to check that. Huh. Why'd we get hung up? Okay. So 11 is home, which that makes sense. It said, no, I'm already home. "21, it said I'm already there. 12, 11, 22, 21. Okay, yeah, that all works. I don't know why we had that little hiccup there, but maybe I was typing it in too fast. We've got like a 60 millisecond scan. But yeah, so we've got all of our commands now. So now we can set up and do things on our HMI that if we push clamp cylinder, it's going to put in an 11. If we're in the sequence and we tell it clamp cylinder, we're going to tell it 22. All right. I know that seems like a lot and it was fast. Next, maybe if I get time, I'll try to throw in the gate, but all that should carry over. And then we need to do our emitter and our conveyor. And then actually we've got all the actuator control. We still need to do positions on this guy and control of each one of these axes. I think our alarm blocks will transfer over. You know, we can use those on them. We might write some custom alarms for the conveyors, like a timeout when moving from here to here, or from here to here, and here to here. And then we need to write some home sequences, some auto sequences, maybe some interlocks, parts counters. We might do some information on what we're waiting on in our sequences. Stuff like that. So probably another 5 or 6 videos and we're going to have this fully up and running. The good news is too, a lot of this will carry over if we wanted to program a different machine, or we could do tweaks with it. So appreciate everybody watching. I hope you enjoyed the video. I'll catch you later.